Hello everyone. So today we'll start the next part of our BPT. Let's see the first question. In which of the following functional group isomerism is not possible? So read the question carefully. Not possible is asked. Let's see what is functional group isomerism first. Two or more compounds which have the same molecular formula but different functional groups. Okay, so these are called functional isomers. Let's see what all are the possible functional isomers of the given options. For alcohols, what we can have? We can have ethers, right? OH and O. For aldehydes, we can have ketones, CHO and C double bond O. For alkyl halides, we cannot have any functional group isomers. Why? Because it is just an alkyl halide. We can anywhere we change the position of halide, it will remain alkyl halide only. So this would be the correct answer. And for cyanide, we have isocyanide. For CN, we have NC. Alright. So this is the correct answer, alkyl halide. Let's move forward to the next question. Which of the following statements are correct regarding this internuclear axis of CC bond? Let's see the statements that are given. Rotation produces rotamers. Yes, this is a right statement because rotation along the CC bond will produce conformers or rotamers. Then we have magnitude of torsional strain depends upon the angle of rotation around CC bond. And the third statement is repulsive interaction between adjacent bond is termed as torsional strain. The fourth statement is ethane has only four conformational isomers. Let's see here first. What is torsional angle or torsional strain? For example, if I have a molecule, okay, the angle between these two bonds or any two of the bonds we take, that will be the torsional angle, dihedral angle. And what, see, we draw the Newman projection of this. It would be this, how it is like this, because the carbon we take, the front carbon here, and the carbon is taken here, and the bonds are taken as this. Then what we have, the carbon number 2 that is behind this. That also has the bonds in the similar fashion. So it is like this. So see here the angle is 0 and the torsional strain is there. Why? Because repulsion is there. See, the groups are aligned together. There will be repulsions between the group. Alright, so that is why magnitude torsional strain depend upon the angle of rotation. This is also the correct statement. If we change the rotation angle, say if we do it like this, then the torsional strain is not there. It is very stable. This is C eclipsed and this is staggered. Staggered is stable. There is no repulsive interaction. The third statement is repulsive interaction between adjacent bond is termed as torsional strain. Yes, this is true. We already saw this now. Ethane has only four conformational isomers. Ethane can have infinite number of conformational isomers. Conformers. Why? Because rotation around CC bond, we can rotate it 360 degree n number of times. Alright, so it need not be like four conformational isomers only. These are obviously more. So our correct answer is 1, 2, and 3. Let's see the next question. Sodium acetate is electrolyzed with water and what is asked? The product formed at NO2. Let's see the reactions for the same. Here. Yeah. On electrolysis, what happens? On electrolysis, this is the reaction taking place. Okay, sodium acetate with water on electrolysis will give ethane. This is ethane, CO2. Then we have at cathode we have H2, and then in solution we have NaOH. Okay, So what is the correct answer according to the options? CO2. So this will be our correct answer. Now let's see the next question. Now we already know the answer to this question. See, dihedral angle of the least stable conformer of ethane. We have already drawn the Newman projection. Okay, this was the eclipsed, and this was the staggered form. And here the angle of rotation is 0 degree, and it is unstable, least stable. All other angles between these two are intermediate. Okay, so their stability would be intermediate, but this is the least stable. There are a lot of repulsive interactions. Let's see. These have eclipsed and staggered, as I told you, and eclipsed is the least stable, while staggered conformation is the most stable. You can see this is for 0 degree and this is for 60 degree. Now let's move to the next question. The compound which shows metamerism is. Let's see what is metamers first. Okay, what are metamers? These are the isomers that have the same molecular formula but different alkyl groups. For example, I have ether. Say I have one chain ether here and one I have here. Let's take it C2H5 and let's take it maybe C3H8 or C3H9, whatever it will be. So what we can do, we can change the number of groups. We can make it CH3 like this, and here we can have C4HN, whatever it will be there. Okay, so these are metamers. They have different number of alkyl groups around the functional group. So see, here it is C3 in the option. Now, if I have this, or whether it is this, it's same, right? The numbering, naming will be same. For C4H10, this is the correct answer. Why? Because the metamers possible are these. See, we have three carbon here, one here, then two, and then we have this and this group. Okay? So, this is possible. In C5H10, there is no oxygen atom or any other different atom that metamer can exist. And in C3H8O, the same is the scenario for three carbon. Okay. Now let's move to the next question. Assertion is given that aniline is a better nucleophile than anilinium ion, and reason is anilinium ion has a positive charge. See, assertion and the reason both are true. Why? Because what is the structure of aniline? Okay, and for anilinium ion we have. Now you can easily see that we have already lone pair here. It can easily donate, but here we have positive charge. It is not able to donate the electrons. So it is a better nucleophile, okay? And the reason also is correct. If anything is a positive charge, it is already electron deficient. How can you expect it to give electrons? Okay. Species can give electrons, not electron deficient. So the correct answer would be one. Now what we have to do, we have to choose the correct order of stability of carbocation using the concept of hypoconjugation. What do we see in hyperconjugation? That the carbocation has how many number of alpha hydrogens? Okay, the number of alpha hydrogens will be seen just a second. Yeah. So these are the options that are given to us. These are the molecules and these are the options. So let's see what is the scenario here. Here we have 9 alpha hydrogen. Because the carbocation alpha carbon is this, and this. Okay. Here we have 6. This won't be counted for alpha hydrogen. Okay? Because it is directly attached to the carbocation. Here we have 3 and here we have 0. So what is the stability? That would be 1, 2, 3, and 4. This. For your reference, these are the hyperconjugating images, structures that are given to us. You can have a look at this that the carbocation, because of the electron density from the adjacent S bond, helps in dispersing the positive charge. Like the electron density will be donated, and then we'll have H positive, and then this carbon is stabilized. You can see here. Okay, yeah, and this is a trend that will always be followed. In 100, greatest number of alkyl groups attached to a positively charged carbon atom. Greater will be the hyperconjugation interaction and stabilization of the carbocation. So keep this thing in mind. Now let's see the next question. The addition of HCl to alkene proceeds in 2 steps. Yes, we already know that. The first step is the attack of H plus ion to C double bond C portion, which can be shown as. Okay, so see, we have to see which arrow notation is correct. Let's see which is correct. See one thing. If there is a double bond, it will always donate electron to a carbocation or any electrophile we have. Okay, electrophile is already electron deficient. Okay, so it cannot give electrons to electron-rich species. So based on this concept, we can already see that which is wrong. H plus cannot give. This is also wrong. So which is correct? This is the correct one. Okay, so but let's see what that in step 1, pi bond creates an electron cloud. Electrophile from HCl. It's the electron cloud and the carbocation is formed. This is the carbocation form. Then what will be the next step? That the nucleophile will be attacking the carbocation form. We will have our required molecule. Chloride will attack, and this will be the final molecule that we'll have, the final product. Now let's see the next question. Choose the correct statement about the addition of BH3 to a carbon-carbon double bond. Okay. What is this? What is the addition of BH3 reaction called? This is hydroboration oxidation reaction. Always keep this in mind and does not follow Markovnikov's rule. Okay, it is a two-step pathway which is used to produce alcohols. Along the double bond, we can add and see this is the reaction that takes place. We have this alkene, and upon adding BH3, we'll have two BH2 here and one BH here. Okay, so it will attach where there are more number of hydrogen, not the lesser number of hydrogen. And when it attaches to more number of hydrogen, it follows anti-Markovnikov's rule. Okay, and let's see if it is syn or ink. You can see it is there in the same plane. Okay, the H is not attacking from behind. Okay, this is not the case. It is attacking from here only, and we can see syn bond is formed. Okay, you already know this is inside the plane. This is out of the plane, and this is inside the plane. If this is the plane taken, and these are on the plane. Okay. So the dash and wedge notation is quite important. Even afterwards, when you will be doing SNR nomenclature. Now let's see the next question. The Wurtz reaction is considered the most effective method for synthesizing methane. The statement 2 says, to dimethylbutane can yield three distinct structural isomers of monofluorinated derivatives. See, first of all, what is a Wurtz reaction? It is used for the synthesis of compounds which have carbon-carbon bond. In methane, we only have one carbon. So no carbon-carbon bond can be formed in methane. Okay. So statement one is incorrect. Let's see statement two. See, this is correct. Why it is correct? Because the structure here would be branched. Okay. In whatever carbon chain we have. So what happens is, let's see this. Here we have CH3, 2 comma 2 dimethyl. Here we have CH3. Here we have C. Here also we have C. Okay. Let's see. Now what happens? You'll see that if upon chlorination we'll have chlorine here, we can have chlorine here, we can have chlorine here. Okay. So these will be the same three isomers. Then we can have it here. These all will be same. Okay, these will result in the same. We can have chlorine here or we can have chlorine here. So what is 1, 2 and 3? Okay, so we have three monochlorinated products. That is statement 1 is incorrect, but the statement 2 is correct. Now let's see the next question. The product for the following reaction. The reagent given here is alcoholic KOH, and here is, see, this is very famous ozonolysis. And here in alcoholic KOH is given if, then what happens? E2 elimination. Okay, so the removal of proton from beta carbon and the leaving of the bromine atom takes place. So what will happen? What product we'll get? Let's see if it is given. No. Okay. See, here it will remove and we'll have the double bond. Okay. So keep this in mind. According to Sedzev rule, the more substituted alkene will be the stable one. So that is the major one. Okay. And in the next question, we have O3. So along this, we will have O3 along the double bond, and then this will be how we can cleave it. So what are the products formed? We have CH2 and C double bond O from this, and from this what we have? We have CH3, C, CH3, H, CH and double bond O. Okay, these are the products we can have. So it would be here. It would be CH3. Now let's see the next question. So let's see the correct statement. Wait. So the fourth option is correct. Okay. In Y plus Z, the given reaction involves ozonolysis of the alkene, followed by the reductive workup with H2OZN. Thus, the product formed are these. Okay. We can do it. It would be better for you to understand. Okay. Now let's see the next question. Which statement regarding the compound X obtained from Wurtz reaction of chloromethane is incorrect? This is the reaction given to us. Let's see. Compound Z can be prepared by coal-based electrolysis. So see what is required in the coal-based electrolysis. It involves the electrolysis of a salt, okay, carboxylic acid. But in Wurtz reaction, we get carbon-carbon bond. We do not have the acid. Okay, so this is the wrong statement. So this would be our answer. It does not involve carboxylic acid. So how can we have coal-based? Now let's see the next question. Which reaction produces alkynate when sodium is treated with liquid ammonia? Sodium and liquid ammonia. Okay. So what it does, it can extract electron from the, it can extract proton from the terminal alkene. Okay. So what is important here? Terminal alkyne. Okay. So the terminal alkyne here is only this. So it will abstract this and we'll have the negative charge here. And we'll have alkynide ion. This would be the alkynide ion, negative charge on the triple bond carbon. Now let's see the next question. How many tertiary carbon atoms present in the product Y? So see what will be the product Y. This will then we'll have bromine attached here. And what happens? Y is this? Bromine will be attached, okay? And this would be our Y. And how many sp3 carbons are there? Tertiary as in these, okay? So the correct answer is two. You see the explanation once what it is given. The presence of two tertiary carbon atom in the product arises from cyclohexene ring structure. In cyclohexene, each carbon here, this is the cyclohexene. Okay, this is sp2. So upon adding bromine, it can become sp3. That is what they are saying. They are capable of forming the four bonds when HBr is added across them. Then we'll have Wurtz reaction. C bond will be formed. Okay, this will be the bond that is formed. So now let's see the next question. Weight of 2 moles of organic compound which is obtained by heating sodium ethanoate with sodium hydroxide in presence of CaO. Let's see the reaction first. This is the reaction sodium ethanoate with NaOH in the presence of CaO. It will give CH4 and sodium carbonate. So what is ours? Moles of the product. Here we have 1 mole. It is 16 gram. We know 12 plus 4. So what will be for 2 moles? 2 into 16, that is 32. So the correct answer is 1. Now let's see the next question. What is the major product of the following reaction? This is the reaction given to us. Fiddlecraft's reaction. Then what is ours? The product. Okay, let's see what is said. Here we have N-propyl group attached to chlorine, chloropropane. Then we have AlCl3. So what happened first? We'll have the formation or the generation of carbocation. Okay. What will be the carbocation form? Okay, but this is not stable. So rearrangement will occur. So hydrogen from here will donate its electron density here. And what we'll have? We'll have CH3, CH3. Okay. This is the structure we'll have. Now, upon benzene ring infusion, what will happen? We'll have finally this product because carbocation is here, Me. Me and CH. Okay. So what is the correct answer? That is option number B. Now let's see the next question. The number of sigma and pi bonds we have to calculate in this structure. What is this structure? This. Pent, 2-ene, 3-ine, 4-ine. Okay. So we can now easily calculate sigma bond. These are the sigma bonds. And two pi bonds. Then here we have two. Okay, two here and one here. So 10 and 3 is the correct answer. You can calculate. Let's see the next question. Identify the following product. This is a reaction given to us. And what are the reagents? It is Zn and HCl. Hg in concentrated HCl. This is a very famous reaction. Which is this reaction? You all should know by now. This is Clemmensen reduction, right? So, what happens in Clemmensen reduction? This becomes this, right? So, which is the correct answer? You see, it's OH, no. OH again, no. Here, so they just vanished the carbon chain, no. Yes, this is the correct answer. Why? Because here we have HH. This is correct. Let's see the next question. Yeah. The given two statements are there, and we have to say which is correct or which is false according to the options given. Where are the options? Here. Okay. Statement one is the boiling point of three isomeric pentanes follow order n-pentane, isopentane, neopentane. And what is given? Statement two, when branching increases, the molecules attain the shape of sphere. This results in smaller surface area for contact, due to which intermolecular forces between the spherical molecules are weak by lowering the boiling point. Okay. See, both the statements are correct here. Why? Because the branched chain, if I have this chain, but then I have this, it has more boiling point. Okay, when branching is there, the boiling point reduces. It decreases. The lower boiling point is there. Okay, why? Because it has a lower surface area than the straight chain isomer. So both the statements are correct. Let's see the next question. The alkane that gives only one monochloro product on chlorination with chlorine. See, which type of alkane can give one? When all the carbons are equivalent, so chlorine attached to any carbon will give the same product. That is the case of this. I can attach chlorine on any carbon, here, or here. The answer would be the same. What is this? This is 2, 2 dimethyl butane. So you can see this is the reaction. We can add chlorine on any carbon. But please don't add chlorine here. It cannot be possible. It is not possible. It is already sp3 hybridized. Now let's see the next question. The incorrect method for the synthesis of alkenes is treating vinyl dihalides with Zn metal, treating of alkynes with Na in liquid ammonia, heating alkyl halides with alcoholic KOH, and the fourth option is treating alkyl halides in aqueous KOH solution. See, we all know these all are the synthesis method for alkenes. but not this. Why? Because in this method, alkene is treating alkyl halides. What happened? Yeah. So alkene is treating alkyl halides in aqueous solution. Because through this method, alcohol is formed. Okay. Instead of alkene, we get alcohol. This is the reaction Rx plus KOH aqueous. Okay. This will give you ROH plus. This is alcohol. So this would be the answer. Let's see the next question. For the given reaction, this is the given reaction, and the reagent is KMNO for an H plus. We know what it does. Acidic potassium permanganate or acidic potassium dichromate can oxidize alkene to ketones or acids depending upon the nature of the alkene and the experimental condition. Here, this is very strong. It will oxidize it to COOH. Okay, it won't stop in between. So we'll have this answer. Now let's see the next question. Compound X on reaction with O3. That is, whenever you see O3, this is ozonolysis. Always keep this in mind. Followed by ZnH2O gives formaldehyde and 2-methyl propanol as product. And the compound X is C. What is 2-methyl propanol? Let's see this. Okay, this is 2-methyl propanol. And what is formaldehyde? So this is formaldehyde. How can we have this? What happens is in ozonolysis, this is formed, this and this. Then these two must have been connected together. Then only ozonolysis could happen here. See, okay, right? So this is how it would have been forward. Then only we got this. So what is the answer? This. This is what is the name? This is 3-methyl bute-1-ene. The correct answer is 1. Now let's see the next question. How many isomers of 1,2-dibromobenzene are possible according to Kekulé? See, if naturally we'll see we can have ortho para meta, that is we can have 3, but according to Kekulé there are only 2. Why? Because Kekulé considers bromine attached to single bond carbons and to double bond carbons. Okay, so this is the answer. Now let's see the next question. For electrophilic substitution reaction, that is electrophile is attacking the presence of halogen atom in a benzene ring. What it does? See, for example, I have X, or let it be chlorine, bromine, anything. What it will do? Hmm? It will deactivate the benzene ring by inductive effect. Okay, it will withdraw the electrons, and the electron density will be decreased at ortho and para position mainly. So what it does? The benzene ring deactivates the ring by inductive effect. Halogens are electronegative and can withdraw electron density through sigma bond. Okay, so it can withdraw electron density, therefore making the ring less reactive towards the electrophiles. They do have resonance effect. That is, you might be wondering that we have seen that this they have resonance effect, but the inductive effect is greater than the resonance effect. Okay, so overall we'll have inductive effect domination. See, as I said, at ortho and para through resonance, it will also increase electron density, but overall inductive effect will decrease. So the correct answer is 1. Now this is very easy. I hope you all can do it now. Correct IUPAC naming is asked. How we will name the product halogen will the halogen will get the lowest numbering here. Okay. Alcohol is the primary functional group. We have 1, 2, 3 here. Here we'll have 1, 2, 3, 4. We can so 3 is better than obviously 4. So what will be the name? It would be 1 bromo because B comes before C and H. Then we have 4 methyl, then M, then C, 5 chloro. No, we'll have 5 chloro here. Why? Because M comes after C. So we'll have 1 bromo, then we'll have 5 chloro, then 4 methyl, hexane 3 all. Okay? Which matches the option? It's 2. So let's move to the next question. What is asked? Identify the products. This is bromination, and then we have this. Okay, let's see. These are the options given to us. Let's see if we have the structures here. No. See, in case of X, what happens? Here we have bromination in presence of H news there. That is the formation of radicals will be there. And which is the most stable radical? 3-degree radical, right? This radical will be the most stable. So in presence of H nu, this will happen and we'll have this. So these will form the bonds and we'll have this. Okay. And this is electrophilic aromatic substitution. This is easy now. We'll be at the product we'll have at ortho and para, but the para is already occupied. So we'll have the product at ortho. Alright. Which option matches? This. So this would be the correct answer. So let's see the next question. Cyclohexene is given to us. And what are the reagents? KMNO4 and H positive. Here we have KMNO4 and OH negative. C. Here we'll have dicarboxylic acid. It will oxidize it and we'll have, okay. But here what happens? We'll have a diol. Why? Because it is syn dihydroxylation. We have OH here. Okay. So what we'll have here, we have a diol. Here is oxidative cleavage. Okay. Here we have a diol. So which option matches? This one. Alright. So this is the correct answer. Now let's see the next question. What is the product that we need to identify as T? This is the alkyne given to us. This is the reagents. Firstly, see when we have 1 and 2, then this is the order in which the reagents are attacking. So first the product from 1 will be found, and then from the 2, and then we'll report the final from the 2. That will be T. What happens in case of H2 and BD and PD and BaSO4, pelletized BaSO4? So it will convert it into alkene through hydrogenation. The hydrogen will be added across the alkyne. It will become double bond. And in second, what happens? This we all know is bromination. Bromine will be added across the double bonds. So we'll have double bonds across this, and it would be then single bond. Why? Because now we have bromine. Okay. So the correct answer is this. This is wrong. Why? Because it would be single bond. Triple bond is converting to double bond, then to single bond. Now let's see the next question. The compounds CH3CH, double bond CH3, and this. These are, obviously these are structural isomers. They cannot be geometrical isomers because the position of double bond is changed. They have the same molecular formula but different naming. Okay. These are structural isomers. So let's move to the next question. Which statement best explains why OCH3 is ortho and para-directing in electrophilic aromatic substitution? I have already told you in the last video about this. What happens? This is OCH3, right? Whenever it will donate its electron density, we'll have negative charge here. Okay, double bond here, then this will be here, we have negative charge here, and then we'll have negative charge here. So it is increasing electron density at ortho and para, and that is a good situation for electrophilic aromatic substitution because electrophile is approaching. It is already electron deficient, and we are giving it even more electron rich carbon. So these are enhancing the electron density at ortho and para positions and making them more nucleophilic. Hmm, Sorry. Let's see the next question. The major product in the following reaction. This is the reaction given. What is asked? The major product. What will be the major product? See, first of all, the attack would be here and carbocation will be formed here. Then rearrangement will be there to get the stable carbocation, and the final carbocation will be formed here. So OH will be formed here. OH negative will approach here. So what is the correct answer? This. Now let's see the next question. An organic compound C4S6 on reductive ozonolysis gives the following gives formaldehyde. What is formaldehyde? This. What is glyoxal? This. When is this possible? This is possible in this case. How? Because This is the scenario. Okay. We'll divide it. We'll have HCO, and this would be, right? So this is the correct answer. Yeah. Okay. Okay. Now let's see the next question. Which of the following represents the correct increasing order of acidic behavior of the molecules? C. sp3. We have sp2. This has most S character. Percent of S character is maximum. That is, it is more acidic than sp2 and then sp3. Let's see. We have ethyne, hexane, benzene, sp, sp3, sp2. No, it does not follow that. Here we have sp3, here we have sp2, here we have sp3. This is sp, sorry. So, what would be the answer? This is correct. sp2 and sp3 for acidic strength. Okay. So, C, 25% S character, 33.33, and ethine has the maximum. Sp is the maximum, 50%. Now let's move to the next question. Match the following. See, now we just have to
Thanks very much
match
for watching me.
these.
Good luck with your preparation. Bye.
So
Hi guys, let's face the truth.
we have isopropyl. What is isopropyl? This group, right? Then we have dimethyl 2,3 dimethyl butanol, and then we have heptane 4-1. This is very clear. This matches here. Okay. Isopropyl will be here and 2,3 dimethyl butanol. Okay. One, two, three. So this would be the correct answer. A3, B2, and C1. Now let's see the next question. The correct statement regarding electrophiles. We already know about electrophiles. They have vacant orbital. They have sp2. Then they are electron deficient or neutral. Okay. Let's see. Electron deficient, that is positive charge, but they are always electron deficient. Okay. For example, I have BF3. It is electron deficient, but it does not have a positive charge. Okay, but it is electrophile. It has vacant orbital. Let's see the statements. Negatively charged, wrong. Here also negatively charged, wrong. Neutral species, totally neutral, no. They have positive as well. C, this is correct. See here, this is electron deficient species that attacks electron rich species. We know this now. Being electron deficient, electrophiles behave as Lewis acids. Okay, so these are the examples of positive charge carrying electrophiles and neutral forms, CbF3, NrCr2. These can be therefore electrophiles can be neutral or positively charged species and can form a bond by accepting a pair of electron from the nucleophile. Alright, so keep this thing in mind. Let's move to the next question. Ionic species are stabilized by the dispersal of charge. Which of the following carboxylate ions is the most stable? Let's see. Wow, this is very stable. Why? It has 2 fluorine and equivalent resonance. What is equivalent resonance? When upon resonation, the oxygen atom is here like So after resonation, the negative charge will be on the same atom and the structure would be the same almost. So this is equivalent structure. Here we only have one fluorine, so still this wins. Here it is destabilizing, it is giving electron density. Here it is somewhat withdrawing but giving as well. Okay, so the most stable is 1. Okay, so now let's move to the next question. See, the best method for the separation of naphthalene and benzoic acid from their mixture is. See, naphthalene here is volatile and but benzoic acid here is non-volatile. It forms a dimer. What we can do, we can sublime. So upon sublimation, what will happen? It will convert from solid to gas directly. What we'll have? We'll have benzoic acid. So what is the answer? Sublimation. It can directly convert into vapor phase from the solid phase on heating and back to solid phase on cooling. So this is the most appropriate method. When it will be in the gas form, what we have, we'll just have benzoic acid. We can separate. Then upon cooling, it will form in solid again. So naphthalene will be generated and separated. Now let's see the number of compounds which obey Huckel rule. Okay, so aromatic species. What is the criteria for Huckel rule? It should be planar. Okay, for example, any ring, anything, it should be planar. These are the criteria for aromaticity as well. Complete delocalization of pi electrons. Complete delocalization should be there. And the presence of 4n plus 2 pi electrons. Okay, so keep this thing in mind. Like when we have n equals to 1, then 6 electrons. If we have n equals to 0, then we have 2 electrons, and so on and so forth. So let's see. Yes, this is planar. Yes, it has 1, 2, 3, 4, 5. That is 5 into 2. 10 electrons. That is n equals to 2. That is why 4 into 2 plus 2 gives you 10. So yes, this is following the all the criterions. This also see it can be like this. So these electrons will be counted. It also has 6 electrons, that is n is 1. It is planar as well as delocalization. So this is also true. This is false. Why only 4 electrons are there? This is in fact anti-aromatic. This is also false. 4 electrons are there. This is true because n is 0. This is also C here. This is non-aromatic first of all. Why? Because it is not planar. The structure is tub-shaped. Okay. This is the structure of this molecule. This is also planar. It is delocalized 1, 2, 3, 4, 5, 6, 7 into 2, 14 electrons. That is n is equals to 3 here. So how many do we have now? We have 4. 1, 2, 3, and 4. Okay. So the correct answer is 4 here. That is option 1. Let's see the next question. Which of the following statement is correct for ethyne molecule? Electron cloud between two carbon atoms cylindrically symmetrical. Yes, this is true. Nonlinear false. This is a linear molecule. One pi bond. No, it has 2 pi bonds. Ethyne molecule consists 2 CC double bonds. No, 1 CC single bond. Sorry, sigma bond is there because 2 pi bonds are there. So the correct statement is only 9 1. Let's see the next question. Iodination of alkanes is always carried out in the presence of some oxidizing agents like HiO3. Yes, why? See, this is what happens here. For example, if I have, then it will give CH3I plus HI. But what happens? This goes back, okay? This is reversible in nature. This goes back. So what we need to do according to Leach-Atelier's principle, we need to move, if we need to move the reaction in the forward direction, then one of the products should be diminished. What we do? We add HiO3 so that it oxidizes Hi to I2, which in the form of vapors can go, can evaporate, and it can just escape the reaction. In the reaction will move in the forward direction. Okay, so this is the answer. Mhm. See, these are the reactions. HiO3, then Hi will give IO2, which is volatile. Or HNO3 also we can use. Okay, this is also an oxidizing agent. Let's see the next question. What type of compounds are aromatic compounds? Now we have already seen cyclic, yes. Aliphatic, no. Saturated compounds, no. It should be cyclic, planar, and all should follow Huckel's rule that we saw here, okay, in this question. So the correct answer is 1, which should have all those conditions. Now let's see the next question. What is the correct order of destability of the following cations? See, here decreasing stability. The donation of electrons is there through plus I. So it is stabilizing. See here, it has a plus I effect. Then what we have, this is plus M. Okay, so it is like very, very, very strong and it stabilizes. Now here what we have. See, now it has minus I. It is not attached directly to the vacant orbital. So it will pull the electron density. It will destabilize. So what is the order? 2, 1, and 3. So this is the correct answer. See, this is what I just explained. You can look at the explanation later. Just pause the video and see. Now we have the correct way of numbering the longest chain of carbon atoms containing functional group is. Carbon atom containing functional group should possess lowest possible number in the chain. Yes, this is right. Always the functional group is given the lowest number. Then what are the other options? Carbon atom containing largest carbon atom should be chosen irrespective of functional group. No, functional group is important. Carbon should exclude. No, it should include. Always inclusive. Okay. So one would be a correct answer. Let's see the next question. It says alkenes are known as paraffins because they are inert under normal conditions, which is true. They do not react with acids or base or other reagents, alkanes. Yes, this is also true. See, alkene has one sigma bond. It does not have a double bond that it can react with any acid or base or form any single bond or triple bond. So both statements A or B are correct. Now let's see the next question. Identify the major product P in the following reaction. This is the reaction given. What is the answer? See, this reagent, what will it do? It will do. Okay, this. Firstly, Hg2 plus and Hg and H plus. What they will do? Here they will form OH. Okay. and then it will tautomerize. See, this is the tautomerizing unit. Okay, OH is here, it will go here and this will go here. Then what we'll have? We'll have this. So this is the correct answer. Now let's see the next question. Which of the following cannot be used to form benzene? This can be used. Three moieties of this will form benzene. This, let's see how many carbon atoms it has. One, two, three, four, five, six, seven. This is the answer. Why? Because benzene has six, it has seven. So what will it give? It will give us toluene. Restol will also give benzene. Okay. Now let's see the next question. Which statement is inaccurate and needs to be corrected? This is the reaction we have. The statement one says reaction involves cyclic helium ion as intermediate. Yes, we have this. Okay. Then what are the other options? Reaction involves carbon and ion. No, this would be our answer. Reaction involves anti-addition. This is true. Chiral atom is present in the product. Yes. If I have Cl here, for example, then this is the chiral product. Cl, sorry, here. Then we have the chiral product, which is chiral. It has hydrogen. Here it has chlorine. So all the four groups are different. Okay. So wait, let's see. The reason why a carbon and ion intermediate is not involved in this reaction is because it goes through cyclic helium ion intermediate. Alright? So our answer would be second. Why? See here, another chlorine atom will attack. So if it is attacking from here, it will go here. So we'll have, okay, and this is chiral. It has CH3 here and it has CH2Cl here. Okay. So I hope you understand it better now. Earlier explanation, you could not have understood that directly. Let's see the next question. Which of the following statements about benzene and its reaction are correct? Halogen in the aryl halide is ortho and para-directing and activating in the nature. Benzene forms triioside and indicates the presence of three double bonds. This is correct. Benzene reacts with chlorine in the presence of light to form hexachlorobenzene. See, only one statement is correct. These two are wrong. This is deactivating in nature because minus IK through it will make it less electrophilic, less nucleophilic. Sorry, and this will not give hexachlorobenzene. It will give hexachlorocyclohexane. So let's see the reactions now. Halogen groups are deactivating groups, and it will form see, right? So similarly for all these. And here, what the product is hexachlorocyclohexane. So only statement 2 is correct. Now let's see the next question. Why does OCH3 group exhibit ortho and para behavior in electrophilic aromatic substitution. Now we know. I've already explained you many times. It is increasing the electron density in orthoid para, alright? When the negative charge is here, we have the double bond here. Then once it will be here, and then we'll have the negative charge here. Then it will go here, and we have negative charge here. So these are the positions we have our negative charge. So what it does, it increases electron density in ortho pair. So that's it. So these all questions are solved. All the best for your next test. Do well. Thank you.